What is collision domain and what is broadcast domain?
Collision domain is a network segment connected by a shared medium or repeaters where data packets may collide with one another while being sent. Also applies particularly in wireless network.
When we enter in Google give us Wikipedia first, right? First few lines of the Wikipedia. He didn't like to go down even.
You can even sense it.
There's another here.
That is really good.
It's a way. So what do you think, sir? Amin, sir?
I get similar.
Your hard work is similar, right? So read what is collision domain. No homework, no one likes Frank.
Creatine is usually happening in the heart.
Sorry, one second. Okay.
Walaikum salam wa rahmatullahi wa barakatuh. I will.
Yes, Frank, sorry.
Yes, this usually happen inside the heart. Two devices or two or more devices want to send packages at the same time.
Good. So silence. Remember one thing. You are part of each and every question. So be prepared.
Because the first one we cannot find.
Oh, you did not find? See, Jun came up with absolutely fine, definition. So according to your definition, Frank, how many collision domains will we have?
Just one.
One only? Andy, what do you think?
Six?
Yeah, what do you think?
Six.
6?
I guess. I don't know.
It's all collision on all the networks.
Respected, sir.
Thank you for your. I would say there's 4 collisions.
4 collisions, intelligent. So you, sir, what your search says?
I just guess.
Definition we know now from Jun, from Frank, and how many collision domains over here now we have according to their definition?
4.
4? So yes, sir. 4? You will go with Sohrab or June?
I'm going according to the board.
Fatima?
Say 6, but I'm going according to the board.
6? How?
Oh, 4.
We don't have even 6 devices there. Give you any idea?
Google says 7.
Google says 7.
Not here, I see 7. So I'll go with 4.
My friend here just said there are no 6 devices here.
I'll go with 5. I'm 4.
Frank said 1, right? And Al Walid said 1. So it's 1. Right? So hub, even we don't consider hub a layer 2 device. So it's we always consider this device as a layer 1 device, hub. So the Boolean domain is 1. The packet, as he said, when we send the packet, and if 2 devices are sending the packet simultaneously, then Boolean can happen, right? So over here, it's not segmenting those devices. So if both devices are sent the packet, they will collide. Any of these devices, if 4 will send the packet, they will collide, right? The collision can happen. So the collision can happen anywhere within this hub. So when we see hub, 1 broadcast domain, 1 collision domain. No matter what, how many devices are connected with hub, it's a collision domain, 1 collision domain. And then I know I have told you it's a 1 broadcast domain. Know how many Korean domains we have? Ami? Nawaz?
I think it should be 4.
Should be
Connected.
4?
That's the switch, right?
Yeah, it's SW main switch here.
I think you can connect 4.
4?
As per the diagram over there.
Your 4 Korean domains according to the diagram.
That's the one.
What about Andy?
6 that right.
Again 6? You are killing us today. He's in funny mood today maybe. So Fatima, how many? 3? Nawaz is saying 4 and then we don't need to differ. Sir? 8? Or only 1?
Top one, collision domain. It should be 4 because it's a switch. But again, I'm confused right now.
Frank?
0.
0 clear domain? Simon? You're saying Frank is 0? You're saying 0?
Not 0.
Pointing to where Frank is saying 0. What does it mean, man? Frank is 0, not 0.
There will be none collision center, I think, because of hub is for the collision, and this one is, I think, for broadcast.
Or even in a switch, there will be collision.
No, it depends on the ether.
See, think in this way. collision is good thing or bad thing? Bad thing. So if switch is more advanced as compared to hub, and we consider this device a layer 2 device, and now if routing capability there is layer 3 device, this same device is layer 3 as well. So there should be less collisions, right? So over here when we come to the switch, each device connected to the port, this one is one collision. So usually traffic doesn't collide there. So whatever we are sending, the communication always happening after the first communication. Whenever device wake up over the internet, over the network, after waking up and they are completing their communications with each other, always unicast traffic is there in switch. Over here, each and every traffic is broadcast traffic. So there can be collisions, right? But over here, when this device needs to talk to this device, there is unicast. One-on-one communication is going on. There is less chances of collision, right? So each and every port is a separate collision domain.
I heard it's like Korean. Is South Korean or North Korean?
Pardon?
South Korean or North Korean?
It depends on them. But for
I
sure,
heard you say Korean.
Simon, but for sure, if you are in in negotiation, there will be collision. You're gonna say to North Korea you are zero, right? And there will be collision, and they will prove themselves. So don't bring politics in the class. The citizens of North Korea are respectful. The citizens of South Korea are respectful. These things are happening in between the governments. So, what is broadcast domain then? In switch. How many broadcast domains are here now? Remember, it's an intelligent device as compared to hub. Don't underestimate this guy. Read. How many broadcast domains?
In the switch network.
Yes, switch. One. Fatima?
The switch, right?
Yeah. Four? See? Four broadcast domains are there. Fatma, how many broadcast domains there now we have?
What is it? Is it
One
router?
and 5.
What is the router?
So sorry guys, whenever I will draw circle with this plus sign is router. And whenever I will type SW is a switch. And hub I always give respect to him with full name. FUB.
5.
Now 5 broadcast domains. And how many collision domains then?
Collision. So I am taking the network.
Better not to get help from there when we are in the class.
Oh no, because you
You-
understand the diagram.
You had a chance to spend plenty of time. This was a homework, right? And Fried done it beautifully. He didn't spend even a second on it.
Okay, so what is that second question? You said collision, right?
Yeah. how many collision domains?
I think,
So in hub we said it's a one collision domain
yeah,
and one broadcast domain.
yeah.
You said here 4 collision domains, it's not. Or you said 1 collision domain or 4 collision domains.
Four, broadcast, I said four. Broadcast,
Over here broadcast 4.
I
So it's broadcast is 1, right?
yes.
First, when we send the traffic, one guy send the traffic using the broadcast IP address, it goes to all of the ports, right?
Yeah.
Where devices are connected. So it's one broadcast domain. And the collision domains, there are 4 collision domains because every traffic is not broadcast traffic. After one broadcast, every traffic is unicast traffic. So unicast is one-on-one. So traffic cannot collide. Collision means when collision can happen. When we are on the road and if accident happens, what its collision is happening right on the road. So when the packets are moving on the roads, they can collide to each other. So the most likely packets collide over here because here we have each and every port separate. Where we are open intersection and everyone is coming, right? Without any signal, the collision can happen more. But if the intersection is, signal is there and even then traffic police guy is there, then very less chances the collision can happen, right? So everyone is following the rules.
Is it so zero?
It's not 0. It means this device is connected to this port, right? I just circle this link. It's not 0. I did not put anywhere 0.
Okay.
So this one is a 1 collision, right?
Yeah.
Collision domain.
I think it depends on the Ethernet connection itself. If it's half duplex or full duplex.
See, half duplex are here. We have full duplex there.
So if there is full duplex, it will be also a collision domain.
Yeah, if full duplex, it depends. Over here, we are not going with the half duplex and the full duplex. Over here, the collision where can happen. The traffic is isolated or not. If the traffic is one way, at a time we just can send or we can receive, there should be less chances of collision, right? We have half duplex traffic when we are in the Ethernet, beginning Ethernets where we had sub hub as well. But we are saying it's a collision domain, one collision domain. So don't confuse with the full duplex and half duplex. Over here, how the traffic is moving, either multiple traffic at the same time or unicast traffic. So, sir, how many collision domains now we have after introducing the router?
How many collision domains?
No, I'm asking why are you staring at me? I'm just kidding. Yeah, how many collision domains? So 2 collision domains. Are you sure? Log it. Then how many broadcast domains then?
2.
Walid, do you agree?
No? That's not right.
His left punch is very close. So he knows he will remain in his limits, right? Good. So how many collision and broadcast domains?
One collision, 4, 5, 7.
1, 2, 3, 4, and you are adding this one as well.
No, I'm adding the one connected to the router.
So you are not adding this one.
Yeah.
Hmm?
One on the top there.
4, 5,
6.
6, and then
The hub itself is 7.
Hub is 1.
Frank, what do you think? Alvarid is saying this is a Boolean domain. So is it a separate Boolean domain then? The rest?
Oh, no, sir.
That's a broadcast.
So this whole is a Boolean domain. It's one Boolean domain. And here we have this one separate, this one separate, this one separate. 1, 2, 3, 4, 5, and 6. So 6 Boolean domains. And how many broadcast domains?
2.
2. So this symbol is always for me explicit. Now how many broadcast domains are there? Frank? 3.
Go with the class.
3. You think 2. Alvarid is saying 3. Frank is saying 3. Only Sayyid knows. Sir, what's the right answer?
Go ahead. Pick a number.
We have a 4.
So the first, when we had only one switch and this one hub, we have 2 broadcast domains. One is this, right? We extended our switch. We didn't do anything, right? If the whole is one broadcast domain. Only router can separate the broadcast domains. We just provide extension. Instead of, for example, 24 ports, now we may have 48 ports. But this guy separates the networks. It connects the networks, subnets, and the most appropriate is it connects the broadcast domain. It separates the broadcast domains. The reason when we were doing yesterday, we said, okay, we have one switch here, and then we had devices, and then we had another switch here with interconnected devices. We said we can connect them using wire, or we can bring a router in between, right? If we are not bringing the router in between, it means there is only one broadcast domain. We just increase the size of our broadcast domain. That's not fine, right? So instead of that, we introduce router. When we have router, then our both sides should be on the separate subnets. But if we are extending using just a wire, then they can talk. If they have both sides, they have the same IP addresses, right? Same sub networks. But providing extension and extension, it's not a good idea. When we are separating the rooms, 5 rooms of this college or 10 rooms of this college, in each and separate lanes, basically we are separating their broadcast traffic. So every network creates broadcast traffic, right? So if we are keep increasing the size of the broadcast, it will going to consume more and more bandwidth, right? And it can bring the system down. So if we need to send just a message to the 10 devices, instead of 10 devices, we are sending the same broadcast message to 100 devices, right? 90 for no reason. 10 are required, but we are sending off hundreds. So always this guy, the router separates the networks and it terminates the broadcast domains as well. Collision domains, each port on switch is a separate collision domain. In hub, the whole hub is one collision domain. And then the broadcast domains, router or hub, no matter what, we have a one broadcast domain. So if we have a switch, how many ports we have now? Then you did not count?
20.
20. Okay, 20 ports we have. How many non-broadcast domains we will have? Broadcast domain. One. Agree? Everyone? Simon? You agree with class? Good. And how many collision domains we have? 20? Good. So can we have more than one broadcast domain on this switch? One switch?
Yeah.
He said yeah.
Yes, we can.
Logically you should say no. No?
Maybe.
No, sir.
For this, yes. Of course, yes.
We cannot complete.
We can have how?
By adding another switch? By adding another switch?
See, we are adding another switch means we are just extending the broadcast domain. Right? But if we are adding a router in between, then we can go for two broadcast domains. My question is, can we go with more than one broadcast domain with one switch? We said one switch is a one broadcast domain. So can we have more than one broadcast domain in one switch? Sandy?
6.
Good one. We can have 6. It's a yes or no. It's Boolean. Yeah, it's Boolean.
To get the answer 6, should I ask okay, man? Okay, so, I mean, what do you think?
It should be one, but unless we need it to add with router and switch and then connect switch with those.
With push on that switch on here.
Man, please stick with this.
It should be one, sir.
Don't route me around the world.
We can use different subnet. Can we use different subnet in one switch? We
With
can, right?
different subnet,
Yeah.
or we can go for different subnet. Believe?
Set up the different IP
VLAN?
address.
What is VLAN?
Virtual local area network.
So Guriz is messing up our concepts. We talked about yesterday LAN, right? And he's saying add V in front of LAN. Why should I put V in, besides LAN?
No need right now.
Right? VLAN. He's saying, okay, don't stick with the physical thing, come to the virtual world, right? So virtual local area network. What is VLAN?
Virtual.
No lead.
So Ralph, you had the same idea?
No. Even without VLAN, we can do it.
How?
You can connect as much broadcast domains to the switch as you want.
How, sir? Please let us know.
So as far as they have different subnets, as Andy said, they will be able to communicate. So each one that's in a different network will be a different broadcast domain.
If you are connecting one subnet here,
Yes.
different, one subnet here, you don't need to create any VLAN,
No.
and they will understand. Okay, we are
Yes, sir.
here. The traffic is isolated, and here the traffic is isolated. Are you sure, man?
100%.
Have you passed the interview?
Oh yes.
Good. You did?
No, I haven't got the call yet.
All right. So I got excited not due to your job. Maybe we are going to get some sweet, right, or treat.
Sure.
So Andy, how without VLAN we can just create the subnets, or we are assigning IP address to this PC different, this PC different, this PC different, and they will be on the different broadcast domain.
Because we have a very intelligent guy there handling
Within the switch. You think Simon is sitting within the switch?
it. Yeah.
No,
yeah.
man. Simon is in front of us. So that's the only way we can have more than one broadcast domain on the switch is VLAN. For VLAN, the second, what the Saurabh is saying, we go with the different subnets, right? Each VLAN may have different IP addresses than the other VLAN. So we have to issue a command to create the VLAN. Only then we can let the switch knows, okay, group these 4 devices separate, group these 4 devices separate. So virtual local area network. As we are saying here, we did in subnetting, we broke our single network to multiple networks. In physical, while sitting in this class and having only one switch, if we want to separate the traffic or separate the broadcast traffic from half of the class separate and half of the class separate, we can go with this concept, right? We can use only one switch. If VLAN is not there, we must have to have at least 2 switches, right? And then the router to route the traffic in between those networks. But using one switch, it's the functionality of the switch. We can separate different ports into VLANs, virtual local area networks. So by issuing a command, we can tell the switch, okay, take these 4 as a separate LAN, and these 4 separate LAN, or the rest 12 separate LAN, right? All 12. So any combination, and we can create even VLAN for each port. So then we may have 20 broadcast domains here, but that meaningless, right? Jim, did you get? Simon? Yes. don't know, board is not good or our duster is not good. See, proven. If collision happens, it doesn't go away immediately. It takes time, right? Cops comes in and then they take care of it. So what is this, honey?
It's a room.
Room? No, Andy?
It's the building.
See? It means I'm really good architect, right? I just draw some lines on this building. So guys, class within a class is not allowed. So we have one building with 3 floors. Finance department here, sales here, IT here. And finance has setting, few guys are sitting on the top floor, few on the second floor, and few on the third floor. See how the building is, floors are coming from top to down. But the top, number 1 should be on the top, right? Before Nawaz says, okay, they are missing. So, sometimes we have settings in the environment when the top management sits on the top floor. And then the different system administrators or different admin guys, they are having the offices on the second floor. And the staff who is facing the customers every day, they are on the first floor. So they can interact with the customers directly. So if they need any support, they can contact here and then they can go talk, right? So each and every customer doesn't need to go on the third floor every day, right? They can interact over here, front side. There is not only management issues, but there can be class issues as well. So they have the unique setup. So all the management guys belongs to finance, sales, or IT. They are sitting on the top floor, and the respective, the same departments, admin guys are sitting over here, and the front-facing guys are sitting on the ground floor. So there, each setup will be different. Kitchen will be different style, bathrooms, everything, right? So we need to set up like this. So all the finance guys, if they are sitting, we have bunch of PCs here. They can talk to each other while sitting on the all separate floors. They can talk here and they can talk over here. So how we can set up? Do we have to have for finance guy one switch here, one switch here, one switch here? And then for sales guy separate switch, the IT guy separate switch. So Frank, what's the solution? using the least amount of hardware. We want to connect them.
We can use one router and the switches for departments. And in each switch, we use VLAN to separate the
So, Simon, do you agree?
Yep.
Jun, say something. What do you think?
Yeah, it's good. It's possible. One router and
Simon is agreeing and you are agreeing. Okay, fine. I mean, you always have broad aspect, right? So from where would you like to start?
We can have one switch with wire connected to all the,
For the whole department?
because it's a simple, you can get wire connected.
Where should I put that switch? On the ground
We
floor
can
or
put it
on
in
the
the
top
main,
floor?
we can put it in the main floor, second floor.
What if there is fight, okay, if admin guys are saying, no, put out on our floor, and managers are saying, no, we want that switch.
It doesn't matter actually where you can put it.
Sir, what do you think, how we can connect them together?
And I think that we should one LAN and connection and one switch, one router.
One LAN, one switch, one router. So LAN is a physical thing,
Yes.
and switch is a separate physical thing. And router another, right? Fred is smiling now.
That's
Stop
actually
smiling.
perfectly.
LAN is not physical.
LAN is a physical
I will take all the departments and put them in a warehouse. All equal.
Now you're gonna pass the exam for sure. So I believe.
I don't know why we need a switch for the finance or the sales. Each department can even by wire transfer. We don't need a switch because one network is enough for the finance, one for the sales and one for the IT. Connecting to the
Each floor has a switch.
You mean to say one switch should be here? Anywhere, right? I'm just, it's not, in the air. So you mean to say all of these can connect here, or you want for each department separate switch?
no, we can connect them all in one switch.
Right. So for example, we are dividing this switch. Frank, you are absolutely right. So we are separating this switch into 3, right? So these guys can connect to this one. This can connect to this portion of the switch, and these guys can be connected here. So yes, sir, what are you thinking?
Just looking. Nothing, I just look. Like what?
No, one switch, we created 3 VLANs, right? We created 3 VLANs. And 3 VLANs, how many VLANs will be there?
9.
Each one.
Hmm?
Each switch we know the whole.
The whole, how many LANs will be there? VLANs. Simon, I asked you before, friend. Sir, how many VLANs? Three? Okay. 9? Three? Say sir?
Three.
No matter what,
No idea.
boss doesn't care. Just he wants communication.
No idea. Okay.
Fatima? So it's the beauty of VLANs, virtual local area networks. As we said earlier, we were able to add 4 ports of the same switch in separate VLAN, and 4 in another VLAN, and 12 in another VLAN. So what we were doing, we were creating the broadcast domains. Over here, we can keep all the departments on the 1 floor, 2nd floor, 3rd floor, and we can associate, maybe for example over here we have 1, 2, 3 or 4. 1, 2, 3 and 4. 1, 2, 3 and 4. And we can group them together. They are sitting on the different switches, but we can group 4 ports from here, 4 here, 4 here. We gonna group them together. And what will be the VLAN then?
VLAN 10.
So, okay, VLAN 10. Then we need to add the port numbers by visiting each and every switch, right? The same VLAN number we are assigning here, same VLAN number we are assigning here. We are telling it, okay, add 1, 2, 3 and 4 ports. These are VLAN 10. VLAN 10, here 1, 2, 3, 4. VLAN 10, 1, 2, 3 and 4. So, and then we may have to repeat the same thing for the second. Then how many VLANs will be there? 3, not 9. 3 VLANs will be there. So 1 VLAN, 2nd VLAN, 3rd VLAN. We are grouping logically the ports in one group. So if we are going 3 VLAN here, 3 here, 3 here, they are again isolated. These ports will be isolated, these will be isolated. They are not going to talk to each other and not with their own departments. And now it's only one switch, right? When we have grouped them together, virtually we are dealing, for us it's a one group switch. Virtually this is a one switch, this is a one switch now. Either they belongs to the same switch, right? So now to talk, to let them talk to each other or separate their broadcast, we need to add a router. And then we will add only one router. Right? And the router will let them talk to each other. So how we create the networks? So VLAN. Who brought VLAN in the environment?
Sorry?
In the discussion.
Yeah.
It was them. We are not even there. But seriously,
Seriously.
The cousin guys,
yeah, we always talk to them.
Why you guys are yawning, man? In this beautiful discussion. NetworkPlus is the very boring class on the planet.
If we create VLANs, if the speed of the switch will be influenced.
Pardon?
The speed of the switch. If we create 3 VLANs in one switch, the speed of the traffic will be reduced or the same.
Only 6.
Good question. Good answer.
Sorry. Can you repeat the question? We have created three.
You will create 3 VLANs in
VLAN.
one router,
One
in one
router.
switch.
One
The speed of the communication of the
The speed,
2 parts, yeah.
the speed
No.
of communication.
It will not affect it.
Oh no, speed is not affected when we are using the switch.
Yeah.
Since we switch is in place now, and it has replaced the hub, there is no problem with the speed. It's not going to reduce the speed. So each connection has its own speed, maintains the speed. If we have 1 gig ports, so the traffic is basically unicast. So it will be 1 gig. It's not going to reduce to as in hub. As many traffic is coming in, the speed is reducing, right? For each connection. Over here, each connection will enjoy the same speed. And the VLAN we are just separating our ports into multiple.
Every 2 parts do not have a clearing, right? Every 2 parts do not have a clearing if they communicate with each other.
They don't have what?
Clearing. Every 2 parts, yeah.
Collision?
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 No.
No collision. No collision. When is unicast traffic, there is no collision. Collision is happen when there is broadcast traffic is there. So, and another thing. So, okay, let's discuss the collision things first. I didn't want to bring those things earlier. It's a too early stage, but okay. We have one thing, CSMA, CD, and CSMA, CA. One is carrier sends multiple access with collision detection and the one is
Collusion.
Detection.
detection. So we have CSMA and CD and CSMA, CA. So carrier sends multiple access. When multiple devices are trying to transmit the data, how the carrier behaves, right? In CSMA, it's like this when we start talking, right? And if I'm excited and as usual, Saurabh is very excited, we will both start talking, right? We both start talking, and then we take pause because both understand what we are doing. We both are keep talking and we are not listening each other. So we take a pause, and then we start talking again, right? The same, our devices are now intelligent. Maybe when they are starting, they start immediately, right? They talk. When they understand, okay, man, no, what's going wrong? They take a pause. They then start listening. Then they listen and then they transmit the traffic. So it's happening in our systems as well. So when any device wants to send the packet out over the media, it sends the media first. Either there is traffic or not. If traffic is there, they hold the packet. They are not going to send the packet out. Where we say it's a detection. Detection usually happen on the wired networks. They are capable enough to detect the collision before it happened, right? So they try to, okay, A want to send the packet B. No, A will first detect, okay, what's going on the road, right? Either road is clear, should I move? If there is no traffic, it detects there is no traffic, it will transmit the packet out and it will be there, right? But if it detects, okay, there is something wrong, some traffic is already going on, it's not going to send the packet. It's like on the roads, we are doing the same thing. In carrier sense multiple access collision avoidance, where we cannot detect the collision before it happens, we go with the avoidance. We try to avoid the collision. We will discuss these things in detail in CCNA. I'm just trying to give you guys an overview. So Andy, since yesterday, is talking about collisions. He's so worried. He doesn't want accidents. So in wireless networks does not have capability to detect the collision. What they do? See, take the example, if a big trailer, what we call the big truck, trailer, the trailer, if it's going to enter the highway, usually they have some agents with them. One of the agent goes in front and he observes the traffic, right? He said, okay, everything is clear, come on. And if the agent doesn't come back, what driver should assume? So my agent has passed away, right? So agent is no more. So then in avoidance, they needs a lot of agents. So when the agent is, he sends the agent, and if he see the agent is alive, it starts driving. Okay, road is clear. And if agent doesn't come back, it assumes, okay, my agent gone. It means road was not clear. It's not the good time to move in. So send another agent, right? How risky job is. So in the same way, this guy over here will send the agent first. Okay, I'm request to send. We use the word request to send. It's a packet. It sends out first. If the packet comes back, it means the way is clear. Okay, send the real data, right? So if the request to send back does not come back, it's gone, right? It will send another request to send message. When what the response is received, clear to send. The packet it receives, when it receives a packet, clear to send, it means now road is clear. Now it's good to move in. So it sends the data out. So in this way, either we are using hub, we are using anything, right? Even in the earlier, we were using bus. Bus was using this one, CSMA CD. So they were able to avoid, detect the collision before it happens, right? So if they send the traffic, if they are not able to detect the media, if they are sending out the packet, even though there will be collisions. And in those networks, the legacy networks, it was hard to manage them. It could be really, really hard. So detection was really, really important at that time. So first detect and then send. So over here is simple. They just see if there is no traffic, they send the packet out. Over here they send the agent, right? First request to send. and then they receive a packet back clear to send, and then they send the traffic. Anything other than configure? Good?
CS and the slash CD.
See. So carrier sends multiple access with collision detection. So carrier sends multiple access with collision avoidance. So yesterday we were comparing in between, hub and switch. We said we take hub as a layer 1 device, no intelligence involved. If we relate to our Ethernet, it was just a bus. They take a cable and put into a box. So the first hub, and then they move toward the switch, and switch can able to create the different packets. How it understand which device is connected to which port? It has 8 port. It doesn't need to understand, right? It just receives the packet on one port and makes a copy and send to everyone every time, whatever the traffic is. Either it's a broadcast traffic, unicast traffic. It makes every traffic a broadcast traffic, right? And it sends out to everyone. And now it's recipient who needs to understand, this packet belongs to me, so I should take it. And the rest needs to discard the message. And over here, each and every port has understanding, this device is connected to this port, this switch has this understanding. How the switch knows which device is connected to?
It sends an agent to each port to gather data, and then it saves it to his its lookup table. It's also called R table. That's how they connect it.
So it sends an agent again.
It broadcasts a packet to all the ports, active ports, to gather information about the host.
Who sends the packet out? Switch. Switch sends the packet out.
Yes, sir.
No, it waits till the first time. It depends on the PC who is connected to the port.
Before this, please tell me why you guys are on different pages all the time.
That is true. He always
Sorry.
So the PC will wait for the switch will wait for the PC to send a packet to any other PC, and then he will take the MAC address of the source. He will keep it in his table.
Simon, if you want to agree, we have now 2 versions. Because remember Saurabh is saying switch sends a broadcast message to learn which devices are connected to its different ports.
Yes, sir.
And Al-Walid is saying the switch waits for the PCs to send the packet out, so the switch can learn which device is connected to which port, right? Sir, what do you think, sir? Al-Walid?
Al-Walid is in legacy, so he won't switches.
Please come up with your own versions. We have two right now.
Yeah, I will say that they listen first.
They listen first.
Already.
I don't know, but I know. Alvali makes his word makes sense for me, so I'll listen.
It makes more sense to you.
And
I'm not asking please agree with Khalid or Saurabh. I'm asking.
No, because he thinks deep. That's the thing.
I'm asking. My question is how. My question is how Switch understands which device is connected to which port, right? I'm not asking either Saurabh is right or Al-Walid is right.
But he takes things deep and
Yeah.
take
So.
everything seriously. So I think I do.
So
Not taking that's a dish.
So that is done.
no, what Fatma said?
He takes seriously everything, so probably he's not taking.
See, you have to go to the interview. So see how we should behave, interact.
Oh my goodness.
Sorry, no.
I'm really disappointed right now. Oh.
Frank, 1 second.
Frank is.
I'm not here.
As you said yesterday, when one port send another port a message, then this port understand that this is belong to that port, so they understand each other, and so they stay. Yeah.
I really appreciate you paid attention. Because in short, I have told this thing yesterday. So, June?
The difference.
No. Forget this one. This stupid guy, I'm eliminating this one. We cannot find this guy anywhere now. When we are learning, believe me, basically we need the current knowledge. The legacy knowledge, just a little bit, so we can understand what was the past and how we are now at the advanced stage. In the industry, hub maybe, if we go with the ratio, maybe 0.0001% companies still have. The guys who are stick and they don't want to upgrade and they don't need to upgrade, right? They are just needing to communicate few devices together. They might be using the hub still, but no more. We cannot find on the shops now hub. So switch. So Saurabh used one word, ARP. That was right. But that ARP message is not being sent by the switch. Here he was wrong. And Al-Walid was right. So the thing is, when we have this switch, and we have connected devices, I don't want my PC in bad shape. So now we have this MAC table. We call it a MAC table. Routers, switches have MAC tables. Not only switches, our devices have MAC tables as well. But right now we are talking about switch. So switch, how it fills out the MAC table. It uses MAC table to send the unicast traffic. When this C will transmit the traffic, it will send out the packet. This guy will see into its MAC table, the switch. Okay, source port and destination, source MAC address and the destination MAC address. So destination MAC address, the switch will see into its MAC table. If it finds that MAC address, it will send the packet directly to that PC or the device connected to that port over here, right? If it's sending, C is sending the packet G to G, it will see, okay, where the G is connected to F07. So what will be the destination MAC address in this packet included? What this G has. For example, we can take it in an example, GG, it's HH. We are just assuming these are the MAC addresses. It should be F5
Yeah.
and written E so E. So if there is a against F07, it has the MAC address G:GG, it will send the packet there. But if it does not have, it will send a ARP request. This PC will send the ARP request first. This PC will generate the ARP request, Address Resolution Protocol, ARP. Address Resolution Protocol. Assume C sends a ARP. Why it sends out the ARP? First thing, when I am saying switch will look into the MAC table, right? PC is sending out the packet, and I said this MAC table will be seen by our switch. So from where ARP is coming out? ARP, as we have discussed in our OSI model, we said when we are sending the packet out, we have source IP address, destination IP address, and we have source IP address, MAC address, and we need destination MAC address as well. So first, to include the destination MAC address into its frame, it needs to figure out what the destination MAC address is. It has IP address. For example, the packet is coming from the top layers. Who remember the top layers? It was application, right? Presentation, session, transport, Next June.
Data link. And physical.
Art is happening on this layer. Right? Before we have typed the message, we have created the data. Up till this we have that data. We have these data's names as well, but we will go into more nitty-gritty when we will be in a CCNA. So we have this data, and then this transport layer, what it will include, the source port and destination port. Network layer will include source IP and destination IP. And now this IP, they are from where they are getting, we will discuss this later, but they know already what the destination IP is. Now against this destination IP, they need destination MAC. Over here on data link layer 2, add source MAC and destination MAC. Source MAC belongs to its own. This device has its own, right? And the destination MAC, it needs to identify. For that, it sends out the ARP request, address resolution protocol request. We usually use the word ARP request. So to know the MAC address of G, if this guy C wants to send the packet to G, and to find out the MAC address of G, it will send the ARP address resolution protocol request adding, okay, I have this IP address. Who is on the network this IP belongs to? And that ARP will be broadcast, right? It will be a broadcast message. And now where ARP will go? It's for broadcast message. What it's using? It's sending out the message to this port. It's coming to this port. It's going there, here, here. These are all ARP requests. And now this guy will discard it. I don't have this IP address. It will check, okay, do I have this IP? No, I don't have. It's gonna discard them. But as soon as this ARP request will hit this port of this switch, now switch knows who is connected on this port. Which device is connected to this port. Means it knows only MAC addresses switch. So now switch knows on his port F01 this MAC CC-CC is connected. Immediately what it will do, it will write down the MAC address over here. F00 C. It will start filling its MAC table as the packet comes here. Now it's packing going out. See, if switch was capable enough to understand which device is connecting where, it should learn right now, right? The message was going to every port. But this guy only knows on the receiving end where the packet, the switch received, ARP request received. And it will write the MAC address of the device that connected on to this switch port. Now the packet is going there, it's sending out the packet everywhere. ARP request is going to each and every connected device. All are discarding that package, but the G is gonna accept that, right? G will reply back. And the packet will come here, ARP, it will send back ARP reply. And when it's sending back, what it's saying, I'm the one who has this MAC address. And this ARP reply, as soon as it will hit here on this port, then switch will come to know, okay, on my port F07, GG:GG is connected. And it will write down here, okay, F00, G, G. And now the switch is I can understand, okay, I'm receiving this packet on this port, and it's saying his destination, ARP reply destination is CC, :CC, right? It will look into its MAC table. And it will find out, okay, CC is connected on port F01, and it will send directly message to F01, right? Now, if whatever type of packet it wanted to send or whatever connection it wanted to get established with G, it will send it out now, this twice, F01, and then G will receive and then send back. And then the session is established now. Now the traffic is coming in and out, but it will be a unicast traffic now, right? Now if this ARP, this CC will send the packet out to A, or maybe A generates the traffic and it sends a packet to E. As packet will come up here, it will fill the port number here, the MAC table. Against the F05, it will write down the MAC address of A. And when it will get back the reply, if it's sending out the first time, again it will be a ARP request by A. So AA:AA. That will be a ARP request, and it will be get written here. And then it will reply back, ARP reply, and then the switch knows, okay, on this port this device is connected. And it will get written into the MAC table. And when MAC table is filled, then the switch will use onward only the MAC table. It knows on which port which device is connected, right? Which MAC address belongs to which port. As it will see the destination MAC address, it will find out here and will send it out the packet. No collision, right? It's unicast traffic now coming in back and forth. Most of guys are sleeping. You guys may have break now.
This is means that also then they will check now they will check.
So guys, please, Frank, can you repeat your question?
Okay.
This one, the one that
Yeah, my question is, if device C send a message to device G, so it first they need to use the ARP protocol to confirm to get the MAC address. So if later the second time they send another package, should it do the same thing?
Yes. So Frank asked me, the first time it's sending the packet, so it's an ARP request, right? The second time it sends the packet, it will be the same thing or separate, right? So we have discussed this thing. Why ARP request? Just this PC, for example, this PC1, this guy A, it has its own MAC table. It has MAC table. This guy has MAC table. This piece switch has MAC table. As we write some data and we want to send, and we over here it's into the form of the packet at layer 3. Usually you guys will notice most of the time we will be keep dealing with 1, 2 and 3 and sometimes 4. Very rare we are there, right? So these are applications, they are related to them systems and other areas, right? The networking guys, layers are 1, 2 and 3. And in some cases therefore otherwise no. First 3 layers. So this guy know the destination IP address, and now we know the data link layer to send the frame out. They need to complete their frame. They need destination MAC address as well. So the PC will look into its own MAC table. Either it has destination MAC address or not. So if it has destination MAC address, it will include within its frame and will send the frame out. It will hand over to the physical layer. Okay, send it out. If it does not have the MAC address of the destination, then it needs to resolve against that destination IP. Now this device needs to know the destination MAC address and how it can come to know using this destination IP address. So then it will send the packet out ARP request. And now if ARP request is coming, and it will come here as we discussed, it will writing the MAC address of this PC. Now it's building its own MAC table. And now its request is coming here. See, its request is coming here, but the switch is not writing the MAC address of this one, right? The destination MAC address is included, but it writing the source MAC address, right, on the receiving port. It comes here, it sends the ARP request back, request came here, it write down okay F02 has now F02 has B. The next time A needs to send the packet now. E has sent out the data, he completed the conversation. After some while, then again this A needs to talk to B. And now what the process is, he will see again its own MAC table. If it has the MAC address there, then he doesn't need to resolve it, right? Then it will use that MAC address with its frame, it will include within frame and send the packet out. If this this PC has MAC address, destination MAC address within its table, it means switch definitely has. Because the communication had happened earlier, only because of that this A knows the B. If A knows the B, definitely the middle guy knows the B. Right? No ARP is then required. This guy is sending with the destination MAC address, switch will look into its MAC table and will send the packet to the B. And the B definitely, when it's sending back, it knows okay from where the packet is coming, right? So it's a source MAC. Now that will be the destination MAC for this guy, the B. It will send out and the switch again knows okay where the A is and it will send the packet here, right? Yes, sir.
So that means ARP request all the time is a broadcast.
If
But
it's
ARP reply all the time is a unique.
universe. So see, ARP when we are sending, only one time, right? When the switch MAC table is filled, we don't need to send the ARP again. It's the when we are just building the network or we are adding a new device to the network, we are connecting new device to the switch. That switch needs that ARP request, right?
So if that means each device they have their own MAC table, and that MAC table is made step by step when they send the packet to other devices.
Open your PC's command prompt. Open the command prompt and type one command ARP -A space -A. On your physical machine, no problem. Yeah. ARP yeah. Any no matter. It's not case sensitive. ARP space then dash then A -A small a. Just click simple. Click simple. And type simple.
It's not recognized.
You have
Right.
You open PowerShell. Go to the host machine. Minimize this. This is your host machine.
This one, right?
So wherever your machine has sent
CMD.
out the packet, you have the information here.
Just type CMD.
Click here. Now CMD. Type CMD. Type ARP.
Yeah. Click here.
Space.
Dash, right?
Space. No space.
Mouse is not working. So type here ARP.
Yeah.
Or-
Enter.
Is there any result or blank? Hmm?
The interface.
You have IP addresses and then the MAC address, right? In the switch, you guys will, when issue the command, you guys will notice, okay, the port number and the MAC address.
I have something like the packet even shows the broadcast ARP and then the packet who has this IP address.
You are always advanced, you know. Good.
Will we see this? That works or?
What is in cloud we have? For example, it can be Google, right? This PC, this has IP address 192.168.10.2. 192.168.10.3. Okay, so I'm writing again and again F01, F02, F03. What is F? Thank you for not asking. Thank you, sir. Thank you. I really appreciate it. So now this guy, we have IP address here. The PC A wants to send some traffic to Google. He wants to talk to Google. So how can he go there now? These are what type of these IP addresses, Jun?
Plus.
No, not class. Is it the public IP or private IP? Classes we have on this side, on that side. Both sides we have classes.
It's public.
Is a public IP? Or what is that 444? So guys, this one is a private IP and that is public. So let me start from this end now. Sir, how do you know? Why it's private? Say yes, sir.
192.168.10. class C and for the private IP. This is for public IP.
Yeah, it's 5
What is the class of this IP, say, sir?
This is class A.
Class A, class C. Within class A, C, private range of IP address, right?
Yes.
192.168. So now internally we have private IP addresses. Externally we need to talk to the public IP. Like this. These private IPs cannot route over the internet, right? They cannot go beyond our own private network. They will stay inside in our private network. It's not gonna go out. So how it will go out? Sir, sign up. Actually, you are watching more carefully, so
How?
yeah, how? So private IPs, and then we have public IPs. In our previous discussions, we have discussed, okay, the private IPs we are using internally, and every second private environment can use the same private IPs, right? We can repeat these private IPs within different environments. But the public IP is unique across the globe. And we may have only one public IP, and that will configure on our router or firewall if we can have gotten 173, 72, 95, 25. For example, we got this public IP from the ISP provider. This side of the network has IP address 192.168.10.1. So this one is my private side, right? And this side of the firewall is facing the internet. So how they will route the traffic, how these things will be get translated to the private IP and it will go out to the internet. What technology we are using? Nawaz?
No.
Oh, your name is Nawaz today?
Yes, I changed my name yesterday.
So Andy Nawaz is saying it's a NAT. So sir, any difference of opinion? Sir, especially. NAT is enough or you want something else?
I would do static routing.
Static.
By the way, sir, not to disturb the class, I just need to leave
Okay,
early today.
no problem. So we have one technology called NAT. Network address translation. What it does, it maps our private IPs to public IPs, and it's the functionality of the router. When we say it's the functionality of the router, and I have drawn a firewall. So nowadays firewalls have router functionality as well. So most of the time we don't use multiple devices for the same things, right? This device can protect us from the outer attacks, and it can provide us the routing functionality as well. we don't need to add router and the firewall. So we go with the firewall then, right? So easy peasy. So then how it will work? If this one is 192.168.10.2 is sending the packet for the Google, what it will include? What will be the source IP? If this guy is sending the packet out, the A, so what will be the source IP? So source IP will be 192.168.10.2. What will be the destination IP?
Destination
192.168.10.1. Who else?
To whom he said the he has to send?
Google.
I think 173.72.95.
Al-Walid is saying 192.168.10.1 and Maz is saying 172.72.95.25. Free. Not sure? What's your idea is? What do you think? What should be? See you, sir.
What is that? 192.
192, 168, 10.1. Frank?
The final destination is Google.
No. I'm talking about when this guy is sending the packet out. A.
Oh.
A is write the packet, right? After writing the packet, it needs to send out. Now it's sending out. We are not going to discuss right now MAC addresses, right? We have done with that. Now we are going to understand what NAT is. We did IP addressing, and while doing the IP addressing, we discussed private IPs and the public IPs, right? So it's the only technology we can understand how it works, right? How private IPs and public IPs goes together, and how we can use these IP addresses in different environments are same. We can repeat these IP addresses in our private areas. So what will be the destination IP, Frank, then? Pardon?
And I changed my answer.
No, log it. We have logged your answer. First time you gave really good answer, so how we can let you change it, right? Frank.
Yeah, we need a few steps to finish that. So first,
No,
send it
we
to-
need first answer. What the IP will be here? Destination IP. Simple. You are saying gateway is 192.168.10.1. Simon, do you agree with Frank? You don't agree with me every time with Frank, right? Fatima, Sanami.
The signal should be like 4.
Sayyid Saab is saying with different answer now. 4. Arjun,
10.1.
Hmm?
10.1.
10.1. Okay, now you can change the answer, sir. Pardon?
I was going 4.
4. No, you with Sayyid Saab, right? Or Sayyid Saab with you. So our destination IP will be here. 4, 4, 4, and 4. So the E wants to send the packet to Google, right? It has typed in his browser www.google.ca, right? And the packet destination is 4.444. Now this traffic has to go from this way, right? We have this port here and then out. When the destination is 444, how it will come here? You both are saying The destination IP is 444, then how packet will come here? Sir Andy,
Yeah.
I want to disturb you. You are on your game or something else. So I want to bring back to the class. Sorry to disturb you.
No, it's okay.
Yeah, we continuing.
It's okay that he's in the
He's busy. Sir, read.
So the switch,
So because switch has the agents. So as you
How
said,
many agents we have in that class?
It's going to drop in a
I took the word agent just to understand the carrier's multiple access, right? And just give a little bit twist so we can enjoy as well.
no, I think the switch, when he looks at the destination,
It's not the switch, the router.
no, he didn't reach the router. You have to go to
Yes,
the
I
switch
will
mode and send it directly to the
router.
default gateway.
It's then it means it's a switch capability. You mean to say
To send it to the default
gateway?
gateway.
So switch knows default gateway.
No.
When we send the packet, for example, I need to send the packet here, right? So what I added there, I added 192.168.10.4, right? And its MAC address, destination MAC address. That's the way switch knows where to send the packet, right? So right now, we have added the destination IP address 4444, right? Then how switch can send it to 192.168.10.1? Switch has a middleman, just it's providing us the connectivity, right?
yeah, because when it goes to all these three, and sees that it's not a destination IP. There's the only way it goes to the 192.168 and the 192. There's a middleman. This is also a middleman who's transporting the package to the destination source as a open.
Yeah. So see, we have, when we are configuring our NIC cards of our PCs, we are telling our PC, okay, if your destination is out of this range, if you find other than 192.168.10, send the traffic to default gateway. It means this packet doesn't belong to our LAN. It doesn't belong to our network. So its destination is out of the network. So default gateway we always configure on our this PC. We tell it, okay, your default gate will be 192.168.10.1. So if you will not be able to find the host, destination host, if you see the packet is including the destination IP other than your local network, send the packet to the default gateway. And if you still want to stick with the switch functionality, then what switch is doing, it will see, this PC will see into the MAC table, either I have MAC address of this 10.1 or not, right? So then it will figure out, through switch, ARP request or those things, where this guy is, right? And then it will include the frame. Right now I don't want to bring the frame into the scenario, but then it will send the packet there, right? Over here right now we have source MAC, destination MAC, with destination is 4444. And the switch will perform its own functionality, and then the packet will come over here 192.168.10.1, but the destination IP will not gonna change. It's gonna include 4444. Over here now, this guy will see, okay, what this NIC card knows, the internal traffic and the external. Now the source is receiving the packet on this port. Destination is 444. Now this one knows, okay, I need to send the packet out, but how? It's the functionality of them. This firewall or router, basically router functionality, it will translate this IP address to 444. But how? How it will change? After crossing this, what will be the source IP then? Yeah. Now it's sending the packet out. Packet arrived to the router. And router is sending packet out now to the Google. What will be the source IP when router is sending packet out? 192.168.10.2 or something else? 173? Why?
It's the other bit.
It's gonna transform to 123.163.3.
Might be 192.168.10.1.
Yeah.
So if this is the source IP 192.168.10.1, is it a private or public?
Private.
Public will route over the network.
No.
Then why you are adding 192.168.10.1? So we bought this IP address 173.72.95.25 from the ISP, Internet Service Provider, to represent our environment to the outer world, right? When we need to talk to the outer world, we are going to use this destination. The most outside the door, right? Where we enter our house, right? Or we exit our house. Internally we have bunch of rooms and different things. That is our setup. We don't give them the address of our my A, B, C or D, right? We always give the address. If anyone Sayyid sir wants to come to my home, I will give him my address, this one, okay? I live here. So internally where we are sitting, it's a different thing, right? So when we are going to talk out, we need to use this public IP address. And this will be the source IP now. So it will keep the information, the router will keep the track from where the traffic is coming. So traffic is generated by A 192.168.10.2, right? And now it's translating this our source IP to 173.72.95.25. And then what will be the destination IP? 4.4.4.4. And it will be going there, right? And now when this guy will send the packet back, the Google will reply back. What will be the source IP then?
What is that?
Source IP will be 444 and destination IP
175. Oh, 70.
173.72.95.25. And now the packet comes here. And this router knows, he has the track, okay, this packet was generated by the A. It will send the packet there. And from this to onward, what will be the source IP?
Yeah, 192.168.10.1. Because it's for inner world.
No, I think it will be the one because this is um, when it's coming to the switch, it's automatically knows it's a one.
Could be yeah. Source should be like 444 because we have sent it. The destination is 444 and it should be source
Good.
should be 4444.
So Sayyasab is the man. You said the same? Good. So now we have source IP 444. Now router is telling this PC, okay, you sent out the data for 444. Now you are getting back the data from source, that was your destination. And then the destination IP 192.168.10.2.
How can be the 444 is a source ID?
From where the data is coming back.
That's polygon environment and this is a private environment.
When we are sending packet out, we put the destination 4444. And our PC knows, okay, this doesn't belong to our network. And if it doesn't belong, use the default gateway. And the packet came over here. Router used its own functionality to map this IP address, the source map, this IP to this IP, right? Our private IP 10.22, 95.25, and now it's using source IP like this, but the destination IP is still same, right? When it will come back, now this PC should know from where the data is coming back, right? So this will be the same while coming back. Now it source IP here. So its source IP will the same as it was before the destination IP. And now the router is telling the PC, okay man, you send the data to this, you wanted to talk to this Google address is this, and now receive it back. So if it's the case, then the communication is happening by mapping the internal IPs to external IPs and external IPs to internal IPs, and that functionality of router, right? We are using firewall as a router here. So in the same time, when this guy was typing, A was typing www.google.ca, this guy was typing www.technet.microsoft.com, right? And this guy, he wanted to go some YouTube video, right? He said, man, class is boring, see some dancing video, right? With some really good sound. So he is listening the song. It's generated another traffic. So all three of traffics are hitting this default gateway. Router is mapping them, translating them with the public IPs and sending it out, right? No traffic comes back. Now its traffic source is different. One is coming from Google, second is coming from Microsoft, third one is coming from YouTube. Or if they are all wants to talk to the Google, now we have three type of traffics, right? It has access maybe the same page, right? That can be the case as well. So everyone is accessing the same page and Google is replying back. Now how this guy can keep track?
Because of their source IP.
Source IP. Page is exactly same, right?
Yeah.
It has track, okay, this packet gets generated from here, this here. But the packet is same. Destination is same. when we are sending out, it will be fine. It can write down, okay, when the data is coming back, data is exactly same. All are accessing the same page. It shouldn't be confused. Okay, now which page belongs to which device?
Because
Then should be the agent, right?
is going to realize this thing because the package sent by the source IP is going to be return the source IP, the whatever the information they are asking from the page. It doesn't matter what it's the same thing. The router remember the source IP.
So he went into deep actually. He did deep analysis.
So you saw dig into deep.
Very deep analysis.
Frank, what do you think? All the router will recognize, okay, if one packet is going out, it can track, okay, this is the source IP and I am mapping this IP to this host, right? Now this public IP. Once it mapped this private IP to this, it can put down, okay, this IP is source and this is the destination. And I am sending the data out. Second time, it needs to map this one. Now there is same information is there. The source IP .4, the destination IP .25, the public IP. Now this router has another information. The source IPs are keeping change, right? But the destination is same. Router has mapped, okay, this one is sending out, a long list. On one of the sites, the router has 192, 168, 10.2, and it has mapped to 173, 72, 95, 25. The second time, .3, 173, 72, 95, 25. The third time, 4. No, the mapping is same. While sending out, when he will receive the packet as the destination, this one, he's saying, okay, I'm generating the packet, I'm 4444, I'm sending to 173, 72, 95, 25, and now the packet comes here. How router will identify from this packet generated, right? From where? Who generated this packet? Which packet belongs to which? The map is like this now. First it knows, okay, I'm the only one. Whatever will come from internal side, I need to replace that IP to my own IP, right? External IP. While coming back, how it can send this packet back.
Probably the order wise. First put some first packet and second packet and third packet according to that. Sorry? Yeah.
So there can be order?
Otherwise,
There can be any order?
the source IP it's mapped. Already it's mapped the source IP, so it have the information about the IP. So while he's doing the map.
I think the router has the it saved all the details of who sent what. Like if 4 of us call you same time with it, it's like tell you something different, and you know that who told you what, and then you're gonna reply as what is said.
We are sitting here, how many people we are sitting here? 2, 4, 6, 8, 10 right now.
Yeah.
Saurabh 11. and Kiri 12. 12 people right now, right? And why Alden is not showing up for last 2-3 days?
His wife's sick.
Huh?
His wife is sick.
Oh, sorry to hear. So I can maybe able to remember who asked what, right? But sometimes I you know, you guys have listened to me, okay, man? Who said that? And if the thousands of the users or hundreds of the users are asking me, okay, map me, I will be mad, man.
For humanity, but
I will be crazy.
for
Yes, sir.
different.
You have done some Google thing?
No, not Google thing. Because if someone is asking, you go over according to the preference. Who asked the first question? You go according to the person.
So how will remember 100 people, okay, man? If there are 50 students, then I will have to ask them, okay, man, who asked? Okay, who asked? Sir, I was first. Sir, no, I was first. No, I was first, man. I asked first. Please reply me back first, okay? And only one guy will be very calm and cool. Simon, he will say, I agree, man. Don't worry. Right? I agree. Sorry, Simon, don't take it personal. I just kidding.
There should be some tracking.
Yeah, so say there should be some tracking. As you guys said, there should be some sequence, there should be some numbers involved, right? So then we have another technology that these both goes together, and that technology always helps this guy to keep the track. What technology is that? Hat. What is that, Believe?
Port address.
So port,
Address.
address,
Translate.
translation. Port, address, translation. Now, when this guy will generate the data, not only source IP, destination IP, it's adding one thing more, the source port, right? And what will be the source port? And then destination port. Destination port is very simple. We know we have which ports are available, well defined. 0 to 1023, right? So altogether 1024 ports are well defined, well known. They are already assigned to different applications, right? So this application will use this port and this will use that port. Which is what port for the browsing traffic, Frank? HTTP traffic, 80, right? So we are talking to Google, so destination port will be 80. And what will be the source port then? F01. Don't confuse with these ports and with those ports, right?
Not same port.
These are switch ports, and they have come up with, it's a fast Ethernet. F means fast Ethernet. Each port has speed 100 megabits per second, right? So it can be G01, gigabit 01. So G means speed is 1000, right? That goes with that. Those ports are different. These ports are protocols ports, TCP IP protocols, and they have port numbers. We have assigned each and every protocol a different port, right? So those 0 to 1023 are well defined. The rest, altogether, how many ports we have, Andy?
65, 65,050.
I believe Frank told me this number. So, this much. And port starts from 0. So, if you want to add up, then add one more number there, right? So 0 to 65,535 ports we have. First 0 to 1023 we are using for different protocols well defined already. The rest we are using here. We can give it any number. And it can be maybe 10. Sorry, not 1023, it's well defined. So add one more 0 here. 11023. So now when the packet will come here, this guy, the first thing it will map this private IP to this. It coming with source port and the destination port. And now when it will send the packet out, what it will be doing, source IP this one, destination IP this one, colon 11.0.2.3. With colon, now it knows, okay, the destination port is 80, but with the colon they are differentiating now which packet belongs to which. When the packet will come back, this port will come along with that. So now the router knows which packet is coming from where. So the same PC is generating another packet at the same time, it will be get associated with a different number. So that number will let the router know, and then that when the traffic is coming back to PC, PC will be able to figure out, okay, which packet belongs to which page. This packet was for Google page, this was for Microsoft page, this was for YouTube page, right? So the traffic, the receiving packet will merge with its own traffic, right? With an own way of the media. So either it was YouTube, it was Microsoft, any TechNet page, or Google. So NAT and PAD goes together. PAD is like this.